Moving on to section 5 of chapter 5. Performing function operations. All right. What do y'all think of when you hear the word operations in math?
Surgery.
Huh?
Surgery.
In math?
It's a game with the guy in the red nose.
Y'all know what the 4 basic operations are?
Is it like division, multiplication, dividing, subtraction?
Yep. Addition, subtraction, multiplication, division. That's what you should think of in math when you hear the word operations. So performing function operations. So let's look at our operations with functions. Let f and g be any 2 functions. A new function can be defined by performing any of the 4 basic operations on f and g. Addition, subtraction, multiplication, division. And you don't necessarily have to write all these down if you can memorize them. F plus g of x just means f of x plus g of x. Pretty easy, right? F minus g of x is f of x minus g of x. F times g of x is f of x times g of x. F divided by g of x is f of x divided by g of x. So you can memorize those. There's no point in really writing those down. Okay? But they give us an example over here. F of x equals 5x. G of x equals x plus 2. So if we're doing f plus g of x, you just take 5x and x plus 2 and add them. Most of the time when we're adding, we're going to be combining like terms. So 5x plus x gives me 6x. 2 has nothing to combine with, so it's just plus 2. Questions on adding functions? Subtracting functions. F minus g of x, I'm doing 5x minus x plus 2. Notice how they used parentheses whenever they subtracted. They put parentheses around that second function. You need to do that. What's going to happen with that negative in that set of parentheses? It's going to distribute. If you don't put the parentheses there, you're going to forget to distribute. So I get 5x minus x, which is 4x, minus 2. Everyone see that? Don't forget your parentheses around that second function that you're subtracting from the first function. Questions on subtracting? Multiplying f times g of x, 5x times x plus 2. Once again, we're distributing. 5x times x is 5x squared. 5x times 2 is 10x. And lastly, f divided by g of x is 5x over x plus 2. There's no more simplifying to be done here, so that's where I'd stop. Everyone got that? I would have this paragraph written down. I would have that written down. The domains of the sum, difference, product, and quotient functions consist of the x values that are in the domains of both f and g. Additionally, the domain of the quotient does not include x values for which g of x equals 0. So let me try to explain that a little better. Let's look at our example right here. Let's just look at the domain of f of x. F of x equals 5x. Is that a linear function, quadratic, cubic, square root function? What kind of function is it? F of x equals 5x. Linear, quadratic, cubic, square root. I can wait. You don't want to take a guess at it. Is it linear, quadratic, cubic, square root? Quadratic. Does it have an x squared term? If it was quadratic, it would have x squared. If it was cubic, it would have x cubed. If it was square root, it would have a square root in it. So which one does that leave? The very first one that I said.
Linear.
Linear. This is a linear function. It just creates a line, right? So there's a rough guess of what the graph's going to look like, right? So domain is my set of which values? X values. So that's from left to right. Do I have a stopping point to the left of this graph? I do? Or is it going on forever and ever and ever? It's going on forever and ever. Do I have a stopping point to the right? Nope, it's going on forever and ever and ever. So what would my domain here be? What? All real numbers, or today we're going to use our interval notation. Negative infinity to positive infinity. It's covering all my x values. Does everyone see that? Is my g of x function linear, quadratic, cubic, square root function? What kind of function is that one? Question?
Yeah, what's the D one?
The what?
Domain.
Oh, yes, domain. Sorry. What kind of function is my g of x equals x plus 2 function? Is it linear, quadratic, cubic, square root? Does it have a squared term? No, so it's not quadratic. Does it have a cubed term? So it's not cubic. Does it have a square root? So it's not a square root function. Linear. Once again, this is a straight line. So what's the domain of this one? Same thing. Negative infinity to positive infinity. So the domain of any of these new functions, f plus g, f minus g, f times g, f divided by g, is the overlap of these two functions. So I'm going to try, hopefully this helps. I'm going to put the domain of f on a graph, a number line. We said it was all real numbers, right? So this whole graph would be shaded. Same thing for G, correct? So the domain of all of these down here, these new functions, is the overlap of my two domains of my original functions. So where are these overlapping? Question?
Yeah, I'm just completely lost. Like, where is...
We're talking about the domain right now
Of what?
of our functions. So we just talked about the domain of f. F of x equals 5x. That's all real numbers.
Okay.
We've also talked about the domain of g is also all real numbers. Now we're talking about the domain of f plus g, f minus g, f times g, f divided by g. Okay? Because the domain of all of those is the overlap of these two domains. So where are they overlapping? Well, what numbers are they overlapping on? All of them, right? If I took this graph and put it on top of this graph, they're overlapped everywhere because they're both covering all the numbers, right? So the domain is the overlap. So what's the domain of all of these functions? It'd be the same thing. So general rule of thumb is if your f and your g have the same domain, then your new function is going to have the same domain. We'll see one in a little bit where it's not where they don't have the same, and we'll analyze that when we get there. Okay? We do need to be careful whenever we have a quotient. Read down here the last sentence. The domain of the quotient does not include x values for which g of x equals 0. So my g of x values in the denominator, when I'm dividing, which value of x would make this denominator 0? What plus 2 would equal 0? Negative 2. So when I'm dealing with my quotient, I cannot include values that would make my domain 0, because because we want, or my denominator 0, we don't want zeros in the denominator. So on my quotient, I'd write it as negative infinity. Can't write. Negative infinity to negative 2, where negative 2 is not included. Negative 2 to infinity. So it's all the real numbers except for negative 2. So the quotient will look a little different than addition, subtraction, and multiplication. Okay? Any overlying questions before I look at my first example? I feel like I'm losing y'all. Example 1, adding two functions. Let f of x equal 3 square root of x and g of x equal negative 10 square root of x. Find f plus g of x and state the domain. Then evaluate the sum when x equals 4. So we're just adding the two functions, right? So I've got my f of x function plus my g of x function. Is everyone good with that? Everyone good with what I've just done? In order to add radicals, I need to have like radicals. Do I have like radicals here? They have the same index and the same radicand, correct? So f plus g of x is going to equal what? Negative 7 square root of x. There's my new function. Everyone okay with that? Adding, not too bad. Now it says to state the domain. So let's look at our domain of f and our domain of g. If they're both the same, then that'll be the domain of my f plus g of x. So what kind of function do I have for f of x? Linear, quadratic, cubic, square root?
Linear.
Square root. I got a square root involved, right? So it's a square root function. Do we remember what the graph of a square root function looks like from last week?
Is it where it has like the dot and it goes up?
Yep. It's that half sideways parabola. So it like starts at 0. It goes up like that. Is that what you were saying?
Yeah.
Yep. Everyone remember that from last week now? Okay. So that's a rough sketch of what 3 square root of x looks like. It's not my parent function. It's a transformation of my parent function. So it's a stretch or shrink of my parent function. So I know it doesn't change position at all. It just kind of changes size of it. So what would be the domain of f here? 0. Not 0, 0.
0
Not negative infinity.
positive infinity.
Positive infinity. It starts at 0 and it goes to positive infinity. 0 is my stopping point because it does not go past 0, does it? Nope, it starts at 0, goes all the way to positive infinity. Does 0 get a bracket or a parenthesis? Remember, a bracket means it's included in the interval. Parenthesis means it's not included. Is 0 a part of the graph? Is it hitting 0?
Yes.
Yes, so it would be included, so it would be a bracket. Did everyone see that?
If you did this, that means it's not included. If you do a bracket, then this.
Yeah, a parenthesis means it's not included. Bracket means it is included. Infinity and negative infinity always get a parenthesis because they're not an actual number. It's just representing it going on forever and ever and ever.
So is it a bracket because that changes 0?
Yep. If I plug 0 into this function, I get an actual number, 0, right? But if I plug anything less than 0 in, like negative 1, I don't get a real number, right? Because I can't take the square root of a negative. Here's a rough sketch of what my g of x function looks like. Something like that. So what would the domain of g be? Is 0 included? 0 is included. Do they have the same domain? They do. So what's the domain of f plus g of x going to be? Yep. It's going to be the same thing. So there's the domain of my new function f plus g of x. Any questions there?
You said it's always going to be the same?
It's not always going to be the same. We're going to see one here in a couple of problems where it's not the same, and we'll look at how to handle that. Okay? Last thing, I have to evaluate the sum when x equals 4. So I'm finding f plus g of 4. So am I plugging into f of x, g of x, or f plus g of x? F plus g of x, I'm replacing that x with 4. What's the square root of 4? And negative 7 times 2. So f plus g of 4 is negative 14. Questions there? The hardest part's the domain. The easy part is the adding and the plugging in to find a certain value. The domain's the hardest part. There's one other way I could have done f plus g of 4. I could have plugged 4 into my f of x and found f of 4. Oops. Square root of 4 is what? 3 times 2 is 6. And I could have plugged 4 in for g of x. What's negative 10 times 2? Negative 20. So I could have plugged 4 into both of those, added those two together. What's 6 plus negative 20? Negative 14. Does everyone see that? Did I have a question? You got it? Okay. Questions on example 1? Kind of getting the hang of it a little bit. Example 2. Subtracting. Let f of x equal 3x cubed minus 2x squared plus 5, and g of x equals x cubed minus 3x squared plus 4x minus 2. Find f minus g of x and state the domain. Evaluate the difference when x equals negative 2. Which function is coming first? F of x. 3x cubed minus 2x squared plus 5 minus g of x. Did I do that correctly? Or am I missing anything? Parentheses around g of x. Right now, if I would have left it like that, it's not telling me to distribute a negative or anything like that, is it? It's just changing the sign of this x cubed term. I need it to change the sign of every term in that g of x function by distributing my negative. So I still have 3x cubed minus 2x squared plus 5. I just changed all my signs, so minus x cubed plus 3x squared minus 4x plus 2. Everyone good with that step? What can I do from there? Start combining my like terms. Three x cubed minus x cubed gives me 2x cubed. Negative 2x squared plus 3x squared gives me x squared. I just have this minus 4x by itself. 5 plus 2 gives me plus 7. Everyone good with that? Can I do any more combining here? I cannot. So here is f minus g of x. Questions on that? Make sure you put parentheses around that second function so you can distribute that negative. Can anyone remember what the graph of a cubic function looks like? Because these are both cubic. Anyone remember? Or do I need to remind you? You need a reminder? It's not a very good one. So something like that, or
So this is, what's it called?
this is a cubic function. So my geometry teacher, whenever I was in high school, he liked to use visuals a lot. And so he would call this one the disco function because it looks like you're posing like a disco dancer. So if that helps you remember, great. Remember it that way. If it does not help you remember, sorry for making you watch me do that. But these are my cubic functions. So can anyone tell me what the domain of f would look like? Or what it would be? What? Negative infinity to infinity. There's no stopping point to the left. There's no stopping point to the right. It's going on forever and ever and ever. What about for g? Same thing. So what's the domain of f minus g of x? Remember, if they're the same, it's the same. So there's my domain. Everyone good with that? Lastly, I'm going to give myself some more room over here.
Is that an F or an X?
Where?
In the last one you just said, domain of
F. So now it wants me to find f minus g of negative 2. So I'm just replacing all the x's in my new function f minus g with negative 2. Everyone okay with how I plugged in? Everyone okay with how I plugged in? Now I just work it down using my order of operations. What's negative 2 cubed? Negative 8. Negative 2 squared. 4. Negative 4 times negative 2. 8. And I have plus 7. Two times negative 8. Negative 16 plus 4. Negative 12 plus 8. Negative 4 plus 7. So f minus g of negative 2 is 3. Questions on example 2? Just make sure whenever you're plugging in that g of x, you put parentheses around it to distribute that negative. We're good there. Example 3, multiplying. We're almost there. Got multiplying and dividing left. Let f of x equal x squared. and g of x equals square root of x. Find f times g of x and state the domain. Then evaluate the product when x equals 9. So I'm just multiplying x squared times the square root of x. Multiplying the two functions. Anyone have any ideas on how I can multiply these two things? Not quite. Is there another way I can write the square root of x without the radical? Not 1 over x.
X 1 over 2.
X what?
1 over 2.
X to the 1/2 power. Remember, if I have a radical, I can write that with an exponent. And if I have the square root of x, that's x to the 1/2 power. Everyone see that? Now, I'm multiplying something with the same base, right? What do I do with exponents when I'm multiplying two things with the same base? Add them. So I get x to the 2 plus 1/2. So I have 2 over 1 plus 1/2. What do I need when I'm adding fractions? Common denominator. What's a good denominator here? What's my new numerator over my first fraction? 4, right? Multiplied 1 times 2 to get to 2. So 2 times 2 give me 4. What's 4/2 plus 1/2? So I get x to the 5/2 power. That is f times g of x. Questions on that one? We good? State the domain. So let's find the domain of f. Is f of x equals x squared? Is that linear, quadratic, cubic, square root? It is quadratic. It creates a parabola. Correct? What's the domain of a parabola? That's upright like that. What? Yep. It's all real numbers because it's going all the way to the left, no stopping point, all the way to the right. Negative infinity to infinity. Domain of g. It's a square root function, right? So it would look like this. This is my parent square root function. So that's what it is. 0 to infinity. Is 0 included or not included? It is included. So are these two domains the same? No. So that does not mean I easily have a domain for f times g of x yet. The domain of f is all real numbers. So that'd be the whole graph being shaded, correct? The domain of g is 0 to infinity. So would 0 get an open dot or a closed dot? Closed dot. Shading to the left or right? To the right. So the domain of f times g of x is the overlap of these two graphs. So if I put these two graphs on top of each other, wherever they're shaded at the same time, it'd be 0 to infinity. Does everyone see why it's 0 to infinity? Once again, if I laid the graphs on top of each other, it's the overlap of the two graphs. So that'd be from 0 all the way to infinity. Anything below 0, that's just the shading from f, right? I want the shading from both of them at the same time. Any questions on that domain? So that's how we handle it if they don't have the same domain. Okay? Can I erase my two graphs? Because now I have to find f times g of 9. So I'm just plugging into my new function f times g of x. So I get 9 to the 5/2 power, which if I type that in my calculator, I get 243. So f times g of 9 is 243. Any questions on example 3? Not too bad. You ready for our last example? Division. Dividing two functions. Let f of x equal 6x and g of x equal x to the 3/4. Find f divided by g of x and state the domain. Then evaluate the quotient when x equals 16. Which function goes on top? F of x, which is? What does f of x equal? 6x. What goes on the bottom? X to the 3/4. Am I dividing something with the same base right here? Are you sure? The base here is x. The base here is, do they have the same base? Huh? Subtract what? The exponents. So let's divide our coefficients first. What's 6 divided by 1? 6. What's the x's in the numerator's exponent? 1. So I get x to the 1 minus 3/4. Remember, if you're subtracting something with the same base, or dividing something with the same base, subtract the exponents. So I have 1/1 minus 3/4. What's a good common denominator? What's that new numerator? 4/4 minus 3/4 gives me 1/4. So f divided by g of x gives me 6x to the 1/4. Questions with f divided by g of x? If you can simplify it, simplify it. Okay, f of x. Is that linear, quadratic, cubic, square root, absolute value?
Was the last one in square root? Or, I mean,
It was quadratic. X squared would be quadratic. F of x is linear. So what would be the domain of my linear function? 0? Here would be the graph of 6x. Negative infinity to positive infinity.
wait, what do we call this one?
Linear. X to the 3/4, that'd be a fourth root function, which looks very, very, very similar to a square root function. So it'll look something like this. So what would be the domain of that? 0, where 0 is included, to infinity. So what would be the overlap there? 0 to infinity. Would 0 get a parenthesis or a bracket? Bracket, are we sure about that? Parenthesis, are we sure about that?
There'd be a bracket included in that. Is there a bracket because that one's a bracket?
Let's think about that first slide that I showed you. The last sentence. Additionally, the domain of the quotient, we're dealing with the quotient on example 4,
So that's how
does not include x values for which g of x equals 0. Which values of x would make my denominator 0? 0. If I plug 0 in there, I get 0 in the denominator, which is what I don't want, because that'd be undefined. 1 would not give me 0. 1 would give me 1 in the denominator. I can have 1 in the denominator all day long. I just don't want 0, correct?
would be a parenthesis.
So I'd get a parenthesis. So it's all the numbers that are greater than 0. And 0 is not included. Does everyone see why we'd get a parenthesis there and not a bracket? You still want the overlap of the domains, but you still don't want to include the value or values that would give you 0 in the denominator. Does everyone see that? So that kind of looks almost like a bracket. It's actually parenthesis. Questions on my domain there? And last but not least, we have to find f divided by g of 16. So I'm plugging 16 into my new function. So another way to look at 16 to the 1/4 power would be the 4th root of 16. What's the 4th root of 16? 2. 6 times 2? 12. So f divided by g of 16 would give me 12. Are there any questions on example 4? Not too terrible? We're ready for the assignment. Since we only have about 5 minutes left in class, we don't have an assignment today. We'll work on the assignment in class on Monday. So make sure you come prepared, ready to work. Bring your notes with you. That way you can use them on the assignment on Monday. Do we have any questions before I end my recording about the notes? How did I get 16? It wanted me to evaluate the quotient when x equals 16. So I plugged 16 into my new function. F divided by g of 16. Does that make sense? Okay. Any other questions before I end the recording?